Okay, so if you and your family were going to drive to Disneyland in California, what are some things that you might want to know about the trip? So go ahead and pause your video right now and just think of some things. You and your family are going to drive to California, like in a car. What are some things you might want to know about the trip before you go? So pause your video, think about a few things that you might want to know, and write them down here. Okay, so a few things that I would want to know about my trip, if I was driving to California specifically, um, is I would want to know, well, how much money is it going to cost me? I would want to know, how long am I staying in California? But specifically centered around driving, I would want to know how long is that drive going to take? Because I hate driving in the car for a super long time, right? So I want to know how many hours am I going to be spending in the car? I'd also want to know how far the trip is going to be, right? So like how many miles am I going to be putting on my car if I drive all the way out to California? And then lastly, I'd want to know, what are the roads going to be like? How fast am I going to be able to drive? Things like that. Um, so there's anytime you go on a road trip in your car, you're going to want to know those things. How long will the trip take? So we call that variable time. You're going to want to know how far is the drive. And so this is going to go by a lot of different names. In physics, we call that position, but sometimes it's also referred to as distance or displacement or length. We're going to call it position in this class. That's why I've got that in bold. But know that that kind of goes by a lot of different names. All right, and then last up is how fast will I be driving? And we call that either velocity or speed. We're going to call it velocity. And at some point during this unit, we're going to talk about the difference between speed and velocity because they're really similar ideas, but they're not exactly the same thing. Okay, and so velocity, that's how fast an object is moving. Velocity is usually given the variable V, capital V, and it has units meters per second. So just kind of like speed, if you remember that from the wave unit. Position, that's the length from where the object currently is to the starting point. So, like for example, let's say you started your trip to Disneyland, and then you made it to Colorado, and you want to know what your position is. Well, that's the distance from Colorado back to your home in Minnesota. So however many miles that is. Position is usually given the variable x, although it could be given y or z, depending, right? When you're doing analysis in more than one dimension, so like maybe the object is moving up and down and left and right, or maybe it's going forward and back as well, right? So depending upon which direction you're analyzing, you might give it a different variable like y or z. But usually x, and to begin with, we're going to give it the variable x. When we start talking about objects in free fall, we might give it a y, but that'll be later. And then position is in science is measured in meters, so it'll have units, meters. And then last up is time. That's how long the object has been traveling for. And then time is usually given the variable t, right, capital T, and then we measure time in seconds, so the units will be seconds. Okay, so this is the velocity triangle. On top we have x for position, and then on bottom we have v for velocity and t for time. So this works just like the other triangles that we've used. If we cover up x, we're left with v and t on bottom, so that means that x equals v times t. If we cover up v, we've got x on top and t on bottom, so that means that v equals x divided by t. And if we cover up t, we're left with x on top and v on bottom. So that means that t equals x divided by v. So those are kind of the three equations that we can get out of the velocity triangle and we can use to solve problems. Let's go through a few different practice problems. A toy car is pushed forward over a flat surface with a constant velocity of 1 meter per second. The car travels for 9 seconds. What is the final position of the car? So we're going to identify our variables to begin with. They tell us that the velocity is 1 meter per second. They tell us that the car travels for 9 seconds, so that's the time. And then they ask what's the final position. So we're looking for x. Okay, so we're going to cover up x in our triangle. And we're left with v and t, so that means that x equals v times t. We're going to plug in v and t into our formula. X equals 1 times 9. X will equal, that says 1 meter. That should say 9 meters. Here, hold on one sec. I'm going to change that real quick. This is slide 33. That should say 9 meters because 1 times 9 is 9, not 1. Okay, and so then we'll go back to preview. And we'll go to slide 33. Okay, good. So then our answer is x equals 9 meters. Okay, example 2, a soccer ball rolls across a parking lot with a constant velocity of 5 meters per second. The ball rolls for 45 meters before it hits the side of a building. How long was the ball rolling for? So again, we're going to identify our variables. First up, our velocity is 5 meters per second. The ball rolls for 45 meters, so that's our position. And we're looking for the time. So we're going to cover up t in our triangle. We're left with x over v, so t equals x divided by v. T equals 45 divided by 5, because x was 45 and v was 5. 45 divided by 5 is 9. T equals 9 seconds. Okay, and then in our last example, we have a jet airplane that travels across a 1,500 meter runway in 30 seconds. So how fast is that jet moving? We've got x, v, and t. X is 1,500 meters. T is 30 seconds. How fast is the jet moving? That's our velocity. That's our unknown. Okay, so then we're going to cover up v. We're left with v equals x divided by t. So then we'll plug in x and t. V equals 1,500 divided by 30. So v equals 50 meters per second, which is a little bit faster than 100 miles per hour. And that's about how fast jet airplanes are going when they take off. Okay, so hopefully that makes sense. If you have any questions, as always, let me know. And then you're going to go ahead and move on and try the practice problems.